So let me just say before I do this, one of the most missed problems that I think this could be the one that finally puts me to sleep, which is good because I need to get some sleep. I'll read it. Since an instant replay system for tennis was introduced at major tournaments, or at a major tournament, men challenged 1,420 referee calls, with the result that 431 of the calls were overturned. So I don't know if you watch tennis or if you're even familiar with any of this. I'm hardly, but I've seen one where they it just barely touches the line. Referee calls it, and then one of the guys, the guy who didn't go for it, throws his racket down and jumps up and down and says, "I want to see the instant replay," and they show it, and sure enough, well, in that case, it actually touched the line, and so he should have hit it. Anyway, going on, women challenged 753 referee calls, and 212 of the calls were overturned. Use a 5% significance level to test the claim that men and women have equal success in challenging calls. Complete parts A through C. And then I thought there were more than that. Nope, that's it, A through C. All right, first part is write symbolically. And I want to do this the way I would normally do this on paper. So what I'm going to look for is the claim. And I'm going to jump right into when it says, we are testing the claim that the men and women have equal successes in challenging calls. In other words, we're talking about proportion. And I'll just go ahead and let the proportion of men be denoted by P sub M, and the proportion of women be denoted by P sub W. And if we're saying that they have equal success, then I'll say that the proportion of men is equal to the proportion of women, and I'm referring to the population proportion of successes. Now remember that proportion in general is determined by the number of successes divided by the total number of possible outcomes. And this little thing is going to show up in just a moment anyway. So if I go to my choices, I don't think I have choices that look like this, but that's okay because they give me indication. They indicate that we are going to consider the sample of male tennis players who challenge referee calls as the first sample, and the sample of females as the second sample. So if they're saying that, then we can change our notation here and say, okay, fine. We're going to call this P sub 1 for first sample and P sub 2 for second sample. And then now that we've got the claim stated, then I go into determining the alternative. So that's the way I do all these hypothesis tests. I first determine what the claim is, and I even write that down. I say, okay, here's the claim. Because remember that your claim is not always your null. So if your claim was, that the proportion was greater, proportion of successes for men were greater, then your claim wouldn't be the null. In this case, the claim is the null, but that's not how I don't assume that the claim is going to be the null. So the logical alternative to that they are equal would be that they are not equal. They are either less than, the proportion of successes for men are less than the women, or are greater than the women. So we'll just say not equal. It's the best way to say that. All right, so now identifying. You always identify where the equality is contained as the null and where the differing statement as the alternative. Okay? So look for the differing statement like strictly less than, strictly greater than, or not equal. And that's your alternative, right? And then look for the equality. Now the equality may have had a less than or equal, or a greater than or equal statement, but where the equality is contained is the null. and that's how you get your symbols. So that's the first step, okay? Which means that we are going to choose not D. Actually, look at D. They've got two statements of not equal and equal, but look how they have them assigned incorrectly. We're going to choose C. All right, so next part of this, next piece of this part, identify the test statistic. Now, you've got review sheets to do all this stuff. Suppose you remember that you're talking about hypothesis testing and you have two proportions, so you remember that from the review page that you want to go here, then you can go here and do the calculation. Boom, 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 that's fine. I would take the time if you really think you need it, you could let me know, but I would only take the time if you needed it to do all this. But we have those numbers because we have p hat given in a roundabout way. So you remember that p in general is x over n. Well, if then we have sample data, then it's p hat, which is going to be x over n, and x and n are from sample data. And then if we have that there's two samples, then it'll be p hat sub 1 will be the x data and the n data, or the n number from the first sample, and then correspondingly there will be the p hat 2 will be the x information, the number of successes for the second set over the size of that set. So these numbers aren't hard to calculate, so we'd have those numbers, we'd find their difference. We're actually assuming right now that they're equal, so what would be the difference of those two? That's an important thing to think about. Let me just kind of restate or translate this statement over here. If we are claiming that they're equal, then isn't this kind of the same thing as saying that their difference, P1 minus P2, is 0? Just keep that in mind, because sometimes that's the way it's worded, or that's the way we need to word it in our mind. Anyhow, so we may be assuming that, but this number we can actually calculate because we have the statistics. Okay, and then minus, and we're assuming they're equal, so that's going to be 0 here. This P bar, Q bar, P bar, Q bar. Remember that when you put a bar over it, it stands for the mean, like X bar mean or Y bar mean. But it's stated right here. We're basically, it's kind of like finding the mean, finding all the successes divided by the total number of possibilities. And then the complement to that would obviously be 1 minus whatever number that is. Okay, so there was a requirement that I ignored over here that says if you're going to do this, n times p has to be greater than or equal to 5, and n times q has to be greater than or equal to 5. Now we're way over this for that problem, but just make sure that you're always qualifying that because there are requirements. If you were going to use the formulas and table sheet, then scoot over here a little bit. Sorry, I'd rather do this. Try that again. Then your scoot in here a little bit, scoot back. You're going to look by chapter. Now, who says you're going to remember that this was chapter 9? In fact, specifically, it's section 9.2 because that's when we did the hypothesis tests and confidence intervals for two proportions. And then in 9.3 we started doing for means and so on. So if you remember that, that's fine. And then we're going to come back to this in a moment. Let me see where your hypothesis tests are here. Okay, there they are. So there's the calculations that we just had. But I'm going to use technology. So I'll either use the TI calculator, Excel, StatCrunch. Well, here's StatCrunch. It's going to be fast enough for me. And I don't have StatDisk, and I mean, I could use it. It would do all the work for me. It would go to the point of making the final wording and final conclusion. So I hit Stat. I choose Proportion. I'm doing a 2-sample proportion, and I have summary data. What's the data? It's given in the problem. So the number of observations that it stated were 1420, and the number of successes, again for sample 1, the min, are 431. Okay, for women, 753 of those were challenged and 212 were overturned. Okay, I hit next, and here it is. Here's my hypothesis test. Now, this actually applies to what I said just a second ago about being able to alternatively think about these. It says that it's a hypothesis test, and your null is that the proportion difference is 0, right? And that is what we were saying, right? We stated it that the proportions were equal, but to say that the proportions are equal, again, is the same thing as saying that their proportion difference is 0. So the difference is 0, and then the alternative statement to that we already have stated as not equal. Okay, and I'll just go ahead and calculate that. Great, so this is going to give me my z statistic and my p-value. It's because I'm doing this with the with the p-value method. So I need the test statistic right here, standardized sample score. Sorry, want that one and that one. Enough jumping around for you? Okay, so I wonder if I can copy. Ooh, look at that! I can copy it. I never knew that. Learn as I go. So I did a Control-C and then I did a Control-V on the PC. Round to 2 decimals is needed, so that we're going to call that 1.07. Makes sense that it's 2 decimals because it's a z-score. Okay, the p-value, usually we use 4 decimals, but this one's only asking for 3. We could have given it 4. So we're going to go ahead and eyeball that 4 in the 10,000th place, so we're going to go with a 2 with no change, 0.285. Again, I'm doing the copy paste. All right, so what's the final conclusion using the hypothesis test? Well, that is done pretty well if you use this wording to final conclusion. We ask ourselves, does the original claim contain the equality? Well, yeah, the claim was the equality, was that there was no difference between them, that they had equal number of successes when they challenged it. So yes, so we're going to go ahead and go down this column. And then, did we reject or fail to reject? Well, that's a good question. That question depends on what we remember about the p-value compared to this to the significance level. And here's what it says. You use the decision criterion to reject the null only if the p-value is less than or equal to alpha, where alpha is that significance level. So what was it? Do you remember? Alpha was 5%. Okay, so the significance level is 5%. And did that p-value turn out to be less than or equal to? No, it's way bigger, right? It's like 28.5% versus 5%. So the p-value, let's come down and answer this question. The p-value is greater than the significance level. Okay, and does that mean that we reject the null? No, because the decision criterion of rejecting the null is done only if the p-value is less than or equal to alpha. Our p-value is way bigger, and if I was to draw a picture here, this is what I'd use to visualize. I've got I've got my scale, and I've got my distribution, And I'm thinking of my critical region cut off by some critical values, and I don't really even care what those are for the sake of this test. Z sub alpha over 2, Z sub alpha over 2. What I care about is that my test statistic turned out to be apparently smaller because when I worked it out, my p-value, the area that's from those extremes, is bigger than the red zone. It's bigger than the critical region. So if it was smaller, you can see why we would reject the null, because then that means we're all in that error zone. But it's not, it's bigger. So we fail to reject. So here it says, this is one way to word it, that you decide to reject the null if it's less than or equal to alpha. Or in other words, we will fail to reject the null because it's bigger than alpha. They're blank evidence to warrant rejection of the claim. Okay, so it's still trying to get that final wording for us. Okay, so let me go ahead and go back to that part. We're going down this column. We just decided that we're going to fail to reject the null. There is not sufficient evidence to warrant rejection of the claim that the proportion of successes for men calling out, making a call against the referee and having it be overturned is equal to the successes of women calling for something to be double checked and it actually being overturned. So there's not sufficient evidence to reject that, they are equal. So that's kind of good, but is that the same thing as saying that we support the claim that they are equal? Isn't that a good question? Is it the same? In fact, I'll go to another, this is that formula sheet again. I'll go to another representation of this final wording. And here it is. There's a whole flow chart for it. Let's see if I can fit it all in. Okay. The thought process doesn't change. It's still a question of, did the original claim contain the equality? In other words, was the claim the null? And we say yes. Okay, so we move over. Did you reject the null? Well, you only reject the null if the p-value is less than or equal to alpha, and it wasn't. It was bigger. So no, we said that we failed to reject the null, so we move over. So then we get to the same thing that we got to as when I used the matrix. Let me go back there. Remember when I used the matrix, I just said yes column and then failed to reject column, or failed to reject row, and then there I was. But what I like about this is that if I scoot it over, it has a little bit of extra commentary, and it says, well, first of all, it's a flowchart. Some people like flowcharts better than matrix. But if I scoot it over, I see this little commentary here. It says, this, meaning this top one, is the only case which the original claim is rejected, and this, the third one down, is the only case in which the original claim is supported. So are we actually supporting the claim? No. If we would have followed through the flow right here, we would be supporting the claim. But what we're actually doing is we're just saying that there's not evidence to reject the claim. That's not the same, technically, as saying that we support it. But I kind of just think of it that way. I just kind of think, well, I'm supporting the claim. But anyways, so there is not sufficient evidence to reject the claim. That finishes the hypothesis test approach. Now we could go through all the stuff by hand, and I could go through all those charts again for the confidence interval, but I'm not going to. we already used StatCrunch eventually to do the test statistic and the p-value and calculate those numbers. You can take that chart, which you've already entered in the x1, n1, x2, n2, and just hit Options, Edit, and go back. Not all the way to the beginning, but just to where you can choose confidence interval. Now you got to choose this carefully because your significance level may be different, but the significant than the default that's already in there. The default is 95%, but your significance level may have been 1%. It says on ours that we were using a significance level of 5%. So this confidence level of 95% is what we want. And I'm going to calculate that and see, look at that, it just redoes it all. And so now I can easily grab, how many decimals do they want? 3? Yep. I can grab 3 decimals without any issue, and just check and make sure that you're rounding them correctly, that you're not just grabbing them, but you're actually thinking about whether or not that last number needs to change. So here's my confidence interval. Ooh, wait a minute. I almost got caught there. Let's see. Did I do the right significance level? Yes, good. Because remember, a 90% confidence level would have an alpha of 10%, but you split it up, so then you're going to have 5%, 5%. Okay, so there it is. And what is the conclusion? Okay, so we're thinking in a different mindset now. We're thinking, is their difference 0? Okay, so that's because saying that they are equal is also like saying that their difference is 0. Logically equivalent. So because the confidence interval limits contains or includes 0, there does not appear to be a significant difference between them, because 0 is well within that, and we're 90% confident that we are netting the value there. So there does not appear to be a significant difference. It appears that it's 0 between the two proportions. Their final conclusion is going to be the same. There is not sufficient evidence to warrant rejection. That part doesn't change. Okay, so this video has been very long, but we're at the end here. Based on the results, does it appear that men and women have equal successes in challenging calls? Well, we weren't able to reject that claim, so we will say that it appears that men and women do have equal successes. And we will check this. Okay, there's the check. And look at it, it's a green check mark. That means we were right. So if you want to pause these slides here at the end, I'm just going to let you see our results again. First of all, how we wrote it symbolically, that we got the test statistic and the p-value. And remember, I ultimately, let me see, maybe I threw that out. I did. I ultimately bailed out and used StatCrunch, but we could have done it by hand. And then we were correct in our initial decision that since the p-value is greater than the significance level, we failed to reject, and so we did not say that there was enough evidence to reject the claim, because in this case the claim was the null. And then remember, when you're constructing a confidence interval that corresponds to the hypothesis test that you did, your confidence interval is not going to be 95%. It's going to be 90%. That way, when you split alpha, you've got 5% still in each tail. So anyway, good question. long video.